Hi all. Welcome to the video presentation for Norton's theorem. Myself, Mr. A. Balachandran, Assistant Professor in the Department of Electronics and Communication Engineering at K.S. Rangasamy College of Technology, Tiruchengodu. Here, that is any two-terminal network that is shown in the figure A. That is any two-terminal circuit which has the two terminals A and B can be replaced by an IN, that is short circuit current or Norton's current, in parallel with the Norton's resistor, or it is also called as a Thevenin's resistance, that is RTH, in between the terminals A and B. This is the Norton's equivalent circuit. Next is how to find the short circuit current or Norton's current, and how to find the Thevenin's theorem, so that is Thevenin's resistor. These are the steps to apply the Norton's theorem. First step is we have to find the Thevenin's resistance of the circuit. That is, Thevenin's resistance is nothing but an RTH. RTH is equal to RN for the both Thevenin's theorem and Norton's theorem. The same procedure will be followed here also to find the RTH. Then next step we have to find the short circuit current. That is, for any load resistor we have to make the short circuit, whereas in the Thevenin's theorem we will make it as an open circuit. But here in the Norton's theorem the load resistor is short circuited. After finding these two, we will replace the values in the Norton's equivalent circuit as we have seen in the previous slide. That is, the Norton's equivalent circuit consists of a single current source with a parallel resistor. That is between the terminals A and B. For that we have to make any energy sources into zero, which means if we have the voltage source, means we have to make it as a short circuit to get the zero. If we have the current source, means we have to make it as an open circuit to make the current zero. The same step is followed here. The voltage source is make it as zero by short circuiting the terminals. After making the energy sources to zero, the circuit will become like this. That is, across the terminals A and B, we have the 40 ohm resistor in series with the parallel of 60 and 20 ohm. To find the RTH, this across A and B, we have to start from the left hand side. That is, 20 ohm resistor and 60 ohm resistors are in parallel. We know that 20 ohm resistor and 60 ohm resistors are in parallel. To make it as a single resistance, we have to apply the reduction of the resistor. That is 20 into 60 divided by 20 plus 60. The resultant resistor will be in series with the 40 ohm resistors. To make it as a single resistance, we have to add with the parallel value of the 20 ohm and 60 ohm with the 40. The same procedure is followed here. After all the calculation, we will get the RTH is 55 ohm. The first step is completed. That is, we have to find the RTH. We have found the RTH as a 55 ohm. Yeah. Here, 40 ohm and 60 ohm resistors are in parallel. We will make it as a single resistance with the same calculation. That is, previously we have seen 60 into 40 divided by 60 plus 40. The resultant value will be 24 ohm resistor. This 24 ohm resistor is in series with the 20 ohm resistor. So that will be added. So 24 plus 20 is equal to 44 ohm. So we will get the single resistance value, that is R equivalent is equal to 44 ohm. Then we have the 100 volt source. So we have only the voltage and resistor. Then we can find the current by using the Ohm's law. So I equal to V by R. Here the V value is 100 and R value is 44. Then I is equal to 2.27 ampere. That is, the total current flowing in the circuit is 2.27 ampere. It is not the ISC or IN. It is the total current flowing in the circuit. That is, I is equal to 2.27 ampere. But here we have to find the short circuit current, that is ISC or IN, which is flowing in the load resistor RL. Further, already I have told we have to use the current divider technique. Yeah, here we can see that here we know the value of I, that is flowing in the 20 ohm resistor. In this place we have the value of current. This will be considered as a current source, and that current is divided between the 40 ohm and 60 ohm. We know the current divider theorem or current divider rule, that is across the 40 ohm resistor. So as per the statement ISC, that is flowing in the 40 ohm resistor, is equal to current source I, that is already we have found it in the previous step, that is 2.2 into opposite resistor 60. Here opposite resistance value is 60 divided by the total resistance 60 plus 40. So 60 by 100 into 2.2. Here 2.2 is a current source, that is the total current flowing in the circuit, which is already founded in the previous step. By simplifying this, we will find the short circuit current ISC is equal to 1.362 ampere. So the next step is we have to draw the equivalent circuit. We already found the value of the equivalent resistor RNS 55 ohm, and short circuit current IN or ISC is equal to 1.362 ampere. That is replaced in the Norton's equivalent circuit along with the load resistance. After finding the short circuit current and the Norton's resistance, we will connect the RL, that is load resistance. Based on the different problem or different values, again here we will apply the current divider rule to find the values, that is to find the current flowing in the load resistor. So far, this is the equivalent circuit for the Norton's theorem. Thank you. Thanks for watching.